Okay, so diamond water paradox. One of the things that had economists kind of flummoxed is why is it that people will pay big amounts for diamonds? Diamonds are something that we don't necessarily need. I mean, diamond is a luxury. Why is it that people are willing to pay such a high amount for diamonds, but water, something that is just indispensable, for life, is something that we don't really spend a lot of money on or are not willing to spend a lot of money on. So they came up with this idea of the diamond water paradox. Now, economists explain this in terms of marginal utility. So what the original explanation was that water is necessary for life, but it's really abundant. It's very plentiful. And because it's so plentiful and because it's so available, people are not really going to receive a much of an additional amount of marginal utility from another glass of water. On the other hand, diamonds are something that are quote unquote rare, right? I mean, you don't find diamonds everywhere, or do you? So because they're rare and they're not the kind of thing that you buy all the time, you're much more likely to get more marginal utility from the diamond purchase you make every once in a while than you would from an additional glass of water. Now, what this is an article from the National Geographic, and I thought this is really interesting. This is talking about a ship that they found that ran aground in 1533. It was leaving Portugal. It was sailing into the Indian Ocean, so it was going around Africa. And I guess it encountered a storm and it got blown into the ocean, and nobody knew where it was. And then they kind of recently, 2009-ish, found this ship. Now, what's interesting about this is that it washed ashore on a beach where a river flows into the ocean. Now, this just happened to be an area that had a lot of diamonds. So if you imagine the river rock, like if you see a river and you notice there's all these kind of roundish shaped rocks there, imagine a river that has is covered with diamonds. Well, that's what we're talking about over here. So diamonds really aren't even rare. They just the people who have marketed diamonds. De Beers have done a good job in controlling the supply and getting people to believe that they're this super rare thing. But diamonds are made out of carbon. Carbon is the most abundant element on the planet. If you were to take coal, which is a very abundant resource, and you were to subject it to lots of pressure and lots of heat, you'd get a diamond. So if there's lots of coal, it probably stands to reason that there's lots of diamonds. So if there's lots of diamonds, why would they be worth so much? Marketing. Good marketing. People who control the supply of diamonds have sold us something, and that's how they get us to pay so much for these things. All right, so let's talk a little bit about a budget line, because now we're going to shift gears and we are going to go to the budget line and indifference curve approach. So imagine that you have $500. That's your monthly budget. Imagine that there are two goods. Why two goods? Because we're working with a two-dimensional graph, so we can only put one good on one axis and one good on another axis. Imagine that one good is gasoline. And let's imagine that at a minimum, you need to buy 100 gallons of gasoline to do your monthly driving going from point A to point B. And imagine, because we don't want to compare, if we're comparing things two at a time, it's going to be really hard to compare gasoline to every other good two at a time. So what we're going to do is we're going to play a trick. We're going to take everything that isn't gasoline and we're going to roll it up into a fictitious good called a composite good. So we're going to take food, we're going to take clothing, we're going to take, housing, we're going to take your computer, your cell service, everything, and we're going to roll it up into a unit of a composite good. And let's just imagine that one unit of the composite good goes for $25. Okay, so we're going to assume that you have to, at a minimum, buy 100 gallons of gas per month. Any money that you don't spend on gasoline can then be spent on a composite good. So if, let's say, you're buying 100 gallons of gas per month and the price of gasoline varies, maybe it's $1, $1.25, $1.50, then the total amount of money that you're going to be you're going to be spending on gas will be 100. If all you're doing is buying 100 gallons, 100 gallons times the price of gasoline That would be how much you're spending on gasoline, and then you'd have the rest left over for the composite good. So let's imagine that you've got a $500 budget. The price of gasoline is $1. You're buying 100 gallons of gasoline. You're spending $100 on gasoline. That means you have 400 left over. If the price of the composite good is 25, that means you can buy 16 units of the composite good. All right, now imagine that the price of gasoline goes up to $1.25, and again, you have to buy, the minimum amount of gasoline you can buy is 100 gallons per month. So how much are you going to be spending on gasoline? 100 times $1.25 is going to be $125. That means that if your budget is 500, you have 375 left over to buy composite good. If the price of this composite good, this fictitious good we invented, is $25 and you have 375 left over, that means that you can buy 15 units of the composite good. And then over here we have the maximum amount of gasoline that you can buy at different prices if you spent all your money on gasoline. So if you had a $500 budget and the price of gasoline is $1 a gallon, you could buy 500 gallons of gasoline. If you had a $500 budget and the price of gasoline is $1.25 per gallon, then you could buy 400 gallons of gasoline. Does that make sense? So what we're trying to do is we're trying to set up a budget line from an example of gasoline compared to all other goods, because that's what we started the lecture doing. So in the case of a budget line, what we're going to do is we're going to have the quantity of one good on one axis and the quantity or number of the other good on the other axis. So let's go ahead and we'll put gasoline on the y-axis and the number of units of the composite good on the y-axis. If we have a situation like this, then if we put all our money, if we have a $500 budget and we spend it all on gasoline, we could buy 500 units of gasoline. If on the other hand, we had a $500 budget and we spent it all on the composite good at a price of $25 each, then we could buy 20 units of the composite good, or we could buy varying amounts. Like this point over here would be spending $300 on gasoline, and it looks like we'd be buying 8 units of the composite good with whatever's left over. So the formula for our budget line is that our budget is going to be equal to the price of Y times the quantity of Y plus the price of X times the quantity of X. Now we can rearrange terms so we can figure out how much of good Y and how much of good X we can buy. So if we're trying to figure out how much of good Y we can buy, why don't we do this? Let's start off by taking this expression, dividing it by the price of Y. So we've got the budget divided by the price of Y is equal to the quantity of Y times px qx divided by py. So we could go ahead and just divide px by py and multiply it by qx. That's okay. And then what we'll do is rearrange terms. In other words, we want to isolate qy by itself. So we'll subtract out the other part of what's on this side of the equal sign, and what we get is the amount of good Y that we can buy is equal to our budget divided by the price of good Y minus px divided by py. Well, px divided by py is very interesting in economics. By the way, I'm not going to have you derive this, but there are things that I want you to know. I want you to know that this is the formula for the budget line, and the second thing I want you to know is PXPY is the relative price of good X compared to the price of good Y. Economists are always concerned with relative prices because no matter what the money prices are, relative prices actually have more significance. In other words, like how many cars does it take to buy a house? Or I don't know, how many pizzas does it take to buy a computer or something? That's what we mean by relative prices. If we wanted to figure out the quantity of good X we can buy, we could go through the same algebra. Again, I'm not going to have you do this, but I just want you to know that because we have this algebraic expression over here, we can figure out the quantity of good Y in relationship to our budget and in relationship to the other good, which would be the good X, or we could do the same thing for the quantity of good X. Does that make sense? And then if we look at L and M, for instance, the way a budget line works is any point along the budget line is a feasible point. Any point within the budget line is also feasible, although you're not using up all your budget. and any point outside of your budget line is at least not feasible with the budget you have. Maybe if you could acquire more budget, you could consume over here at good M, but at M, but at this point you're confined to points along the budget line and this interior point, which we call L. All right, so like I said, the slope of the line is px divided by py, which is the relative price of one good in terms of the other. And we can, if we wanted to, we can solve for the quantities of either x or y. All right, I'm going to go through here. I mentioned a little while ago that good M or M was not a feasible point given a budget line like this, but what would make M a feasible point? If, let's say, we were to get more budget, maybe our income goes up or our wealth goes up or something like that, this point M that wasn't feasible when we were on this budget line over here might all of a sudden become feasible. The reason I mention changes in relative prices because what we're saying is the price of gasoline has not changed and the price of the composite good has not changed. The reason that we're able to shift over here to M is because we acquired more budget. All right, what about L? We mentioned that L was an interior point, and if you were trying to maximize your budget, you might not want to consume at L. Could there be a situation where L could be on your budget line? The answer is yes. What if your budget changed? What if you had less budget? What if, how would we show less budget? We'd show that as a leftward shift in the budget line. So now maybe L is not only feasible when we had this much budget, the budget that puts us on the blue line, but maybe if our budget goes down, L is a point that's on our new budget line because we have less budget. All right, what would happen if there was a change in the price of one good? So let's start off with gasoline. Let's imagine that the price of gasoline went up and the price of the composite good didn't change. Well, we would show this as being a pivot. So how does this pivot work? The change in the price of gasoline is not going to affect the quantity of the composite good that we can buy if we were spending all our money on composite good. So both these lines are going to intersect the composite good axis at 20 units. But because gasoline is more expensive, let's say it went from, I don't know, $1 a gallon to $2 a gallon, now if we were spending all our money on gasoline, we wouldn't be able to buy nearly as much gasoline. When the price is $1 a gallon, we can buy 500 gallons of gasoline. When the price goes to $2 a gallon, the most we can buy is $250 of gasoline. Does that make sense? So that's what happens when there's no change in budget and there is a change in the price of, there's an increase in the price of one of the goods, in this case gasoline. All right, what would happen if the price of gasoline went down? So let's imagine that the blue line represents a budget line where the price of gasoline is $1 a gallon and the price of the composite good is $25. We're saying there's going to be no change in the price of the composite good. So if we're on the blue line or on this red line, orangish line over here, we're still only going to be able to buy 20 units of the composite good if our budget is $500 and we spend all our money on composite good. But now if the price of gasoline were to go down, let's say from $1 to 75 cents, the budget line would pivot on this point, but it would pivot outwards. So if we were spending all our money on gasoline and the price was $1 a gallon, we could buy 500 gallons of gasoline. If on the other hand, the price of gasoline went to 75 cents a gallon, we could now buy something like 750 gallons of gasoline because the price went down. Does that make sense? So this is a budget line with a price decrease in gasoline. I'm going to end it here because this is indifference curves are the second part of this or of a budget line indifference curve, and so we may as well just do that in a new lecture.